Hokie dokie. Second example for this problem. This one will be much faster and actually a little bit easier than the previous example I worked out because the last one used ease and chain rules and product rules and things, and this one is much more simple. It's much more direct, I guess, in terms of the process. So let's go ahead and start. We want to start by finding the first derivative of this function. So we bring out the 3, we have 9t squared, and we just leave it over that 2. Anytime we have constants in the bottom, we'll just leave them as so. So then 2 times 63 is 126, t to the first, or just t, leave it over 4, and then plus 45. This is our first derivative. We might be able to simplify the 126 over 4. So maybe we would have actually gotten just 2 and 63 if we reduced this or had done this derivative a little bit differently. So this is y prime. This is the rate of change function that we want to find a minimum of. Therefore, we will take its derivative. In other words, find y double prime. So doing that same derivative process, we'll get 18t over 2. 18 over 2 is 9, so we have 9t, and then just minus 63 over 2. We set this equal to 0, and our goal is to solve for t, so we add 63 over 2, divide by 9, so 63 over 2, and then dividing by 9 is basically multiplying by 1/9. 63 over 9 is 7. So the t value, where the minimum should occur, is 7 over 2. But they don't want the t value, they want the minimum rate of change. And our rate of change equation was y prime. So we are going to plug t equals 7 over 2 into y prime. So let's give it a go in Desmos. So plugging 7 over 2 into y prime. 9 times 7 over 2 squared, all divided by 2, minus 63 times 7 over 2 over 2 plus 45, and we get negative 10.1. All right. Oh, and they have some lovely fractions here. And so what you could do is plug these values in as division, like division operations in your calculator. So like negative 27 divided by 4, and see if it equals negative 10.125, and so on. You could try that with the other options, but in Desmos, I'll just hit the fraction button over on the top left here, and we get negative 81 over 8. Was that it? Yeah, over 8. There's an option for 10, so I just wanted to make sure. All right, D is our answer. So regardless of the complexity of the function, the process is still the same. So make sure you know your derivative rules with specifically chain and product rule. The process is find the first 2 derivatives, set that second derivative equal to 0, solve for t, plug that t value back in to y prime. All right, hope this helps. If you have any questions on derivatives or this process in general, please let me know.